Alright, this is problem 1091, medium difficulty, shortest path in binary matrix. So n by n matrix return the length of the shortest clear path. If there is no clear path, return -1. Clear path is a path from top left to the bottom right, such that all the visited cells of the path are 0. All the adjacent cells of the path are 8 directionally connected. The length of the clear path is number of visited cells. So here, all the visited cells have to be 0, so you can't hit like a 1. So that's why it goes from 0 to 0. Here, you have to go to the right. You can't go down because of the 1s. You can't go diagonally because of the 1s. Here, you can go diagonally because it's shorter than going right and then down again. And then that's... So it's basically 1, 2, 3 moves, and then +1 goes to 4. 1 move plus 1, so you get 2 here. Here, this is not possible because we start at a 1, it has to be a 0. Okay. So we know we had to start with the top left cell. And we also know that, so if grid of 0 and 0 equals 1, we know this is impossible, so we're just going to return -1, as we have right here, the last, this last example here. And then we're also going to need to keep track of the number of rows and columns. So it will be length of grid, length of the first row. So we know these things. So to iterate through all the different paths, but then get the minimum one, what we could do is we start with a given path, we look at all his options, and then we say that's like one step. Then, so let's, maybe it's better to draw an example. 0, 0, 0, and then 0 here, 1, 1, 0, let's put this 0, 1, 0, 0. Okay, so when we're at RC or IJ, well, I guess we can call RC equals 0, 0. It has just 3 options, here, here, and here. So implies we can call this like next queue is going to be 0, 1, 1, 0, and 1, 1. So then, so this is like, let's call this like I equals 0. So then I equals 1 is the next iteration. So let's say Q is now, so RC we're going to iterate through all of these. So 0, 1, then 1, 0, and then 1, 1. Okay, so 0, 0, we'll just mark this as like an X so that we know we already visited it. So 0, 1, we're here now. So we know we're not going to go back to the cell we already visited. We can add this, so it's going to be 0, 2. And then here, we don't want this or this because they're already in next queue. We already added them. So another option we could do is, so how do we deal with this? So we could either mark, since these were added to the next queue, whenever we add something to the next queue, we can mark it as an X, as an option. Yeah, that sounds like, but then, no, we can't just mark it as an X because then, let's say we mark this X and X, this is an X, and this is an X. So then when we go to the 0, 1, we're going to see that it has an x, and then we're going to think we already visited it, but we haven't actually visited it yet. So we're not going to mark these as x's yet. So what we could do is when we visit 0, 1, then we can say, so 0, 1 implies, so now mark it as x, and then next q equals 0 and 2. So now 0, 1 would be x here. And then, but then how we know we're not going to add 1, 0 and 1, 1? So we could add them, and then in future iterations, we know we'll just skip them because we can mark them as a 1 afterwards. Because here we're going to mark them as an x. So once we iterate through these, because like, you know, down here, we're going to have I equals 2, and then RC equals 0, 2. And then in that case, yeah, this 0, 1 would be the x. These would be x's. So we know we're not going to visit these again. So that's why we can mark it as x after we pop it out of the next queue or whatever. So in this case, so we are going to add 0, 1. Yeah, so we are going to add these two elements here. So those would be 1, 0 and 1, 1. Okay, so now the 1, 0. So now we mark it as an x. 1, 0. And then, so we're going to have the 0, 2. This is an x and this is an x, so we're not going to count them. And then 2, 1. And then here are the 1, 1. So these are all x's, and then now we get the 0, 2 and the 2, 1 again. Oh wait, no, 1, 1, yeah. 1, 0. Oh, 1, 0 is here. Oops, so... Oh, so it's only 1, 1. It doesn't have 0, 2. Okay, so now we go to the 1, 1. Now we mark it as an x. So 1, 0 is an 1, 0 is an x. 0, 1 is an x. 0, 2 not visited yet. It's not a x. And then here 2, 1. Okay, so now we go to, so we went through all of these. So now we're at I equals 2 now. So 0, 2. So now mark it as an x. 0, 2. Okay, so that's this one here. So now it's only going to have this 1, 1 here. Okay, wait, so I equals 2. So Q equals this. Oh no, all of these will get added. Okay, so 0, 2 is marked at x, and it just has 1, 1. Because now we go to this. So now we're at 1, 0. 1. Yeah, so 1, 0 is already x, so skip. Okay. Then we go to 1, 1. That's this 0 here. It's only going to have 2, 0. And then we mark it as an x. So 1 was an x, and then we just add the 2, 0, which is this right here. Oh, and then also this right here. So that's going to be 2, 2. And so now 1, 1 again, but 1, 1's already an X to skip. 0, 2 already an X to skip. And then the 2, 1. So row 2, column 1, yeah. Row 2, column 1, we mark it as an X. And then we're just going to have 2 and 2. And then now we're at I equals 3. Q is the next Q, which is just so 1, 1, 2, 0, 2, 2, and 2, 2. So here 1, 1, there's already an X to skip it. That's here, this one. 2, 0 is a 1, so it's already 1, so skip. Wait, 2, 0. So this should have never been added in the first place. Okay, so we're at 2, 2. And R equals 2, 2, which is bottom right. So we're done. Return I equals 3. So for this one, it started as 1, 2, 3, and a plus 1, 4. So it's going to be, yeah, I equals 3 plus 1, which is 4. So looks like that's the algorithm, and we should be able to just code this now. Okay. I equals 0, Q starts with 0, 0, while length of Q greater than 0. We go through this stuff here. If we finish iterating through the Q and then we don't find the answer, then we're going to return -1. And then we're going to iterate I at the end of the loop. And then, so we need if, or so for RC in Q, if R equals R minus 1 and C equals C minus 1, doesn't say anything about if it's going to be 0 or not, but and grid of R C equals 0, then return I plus 1. Otherwise, yeah, so we pop it and already in X. Yeah, so instead of marking it X, we'll call it just like 1. So basically we're only going to perform logic if it's 0. So if grid of R and C equals 0, then we're going to do some stuff. Otherwise, if it's 1, we just skip it. So in that case, we need a next Q. Close an empty list. So for, call this like Y X in the 8 different directions. So we could have 0, 1, 0, minus 1, 1, 1, 1, minus 1, minus 1 and 1, minus 1, minus 1, 0, minus 1, minus 1. See, so it can go up, left. Oh, so these are, oh, these were the diagonal. Okay, so we now, this is right and, or right and left, so now we need up and down. So up would be minus 1 and 0, and then down would be 1 and 0. Okay, so those are 8 directions. If r plus y is within 0 and r, and c plus x is less than big C, and grid of r plus y, c plus x equals to 0, then we can add it to the next queue. And then do we mark it as 1? Oh, so after we pop it, after we pop RC from the queue, then we mark it as 1. And then look at the what is neighbors to see which we're gonna add to the next queue. So right here, so yeah, here we're gonna have grid of R and C equals to 1. No, that's not right, because then we're doing if grid RC equals 0. Okay, so now mark. Oh, okay, so if. Oh, okay, so this is inside this. Yeah. And if it's already 1, we just skip all this. So it looks like this should work. So let's just run it. Oh, I forgot to set Q equals to the next Q. Let's see if there's anything else I'm missing. So you got this. We're at 0, change it to 1, and then add all his neighbors. Yeah, now mark it as X. If it's already X, skip it. Okay. Okay, so now it should work. And it passes all test cases. Okay, so that's it, and thanks for watching this video.